Hi, I'm Ben Wagner, and today I'm going to be talking about the relationship between position, velocity, and acceleration. Now, through PEP 300, this is a topic that really clicked with me and I really understood. Also, through taking physics in the past as well, it was something that I really understood and was still interested in as well, so I chose that to talk about. And to begin, we should define by the textbook each position, velocity, and acceleration. Now, according to teachengineering.org, position is defined as an object's location relative to a reference point. That can be in the positive or negative direction. And the derivative of this would be the velocity, which is the rate of change in an object's position with respect to time. So if an object were to move a certain distance over a certain time, that would be the velocity. Now, the derivative of the velocity then would be the acceleration, which is the increase or decrease of velocity of an object. So if an object were to move to a different position over a given time, it is how fast or slow that object is changing speeds in the positive or negative direction. Now for me, I'm a much more visual learner, so I like looking more at graphs, such as this one. So for me, position is defined as where a measured object is in relation to its original position. So in this graph, the first graph is the position, and the origin is at 0 seconds at 0 meters, and then it moves away from that around 150 meters at about 15 seconds, and then returns back towards the origin but never reaches it or passes it in the negative direction. Now on this position graph, there are different points. There are minimums, maximums, and inflection points. The maximum is where the object reaches the furthest distance from the origin at around 15 seconds at about 150 meters from the origin. Inflection points, on the other hand, are points where the object is changing position at the greatest rate, which is reflected in the derivative that becomes the velocity graph. As stated previously, velocity is how fast the object is changing positions at a given time. And as I mentioned previously, it is the derivative of the position graph, and the inflection points become the maximum due to the maximum rate change of position of the object. Acceleration, on the other hand, is how fast the object is changing velocities at a given time in the positive or negative direction. This is also reflective of the derivative, again, of the velocity graph. As you can see in the velocity graph, the point at which the velocity becomes constant is where the acceleration will change back to 0. And as it begins to decrease again towards 0, the acceleration goes in the negative direction due to the decreasing velocity. As velocity reaches its minimum, it becomes the new maximum of the acceleration due to its changing velocity back in the positive direction. Now to give a real-world example of the relationship between position, velocity, and acceleration, we're going to look at this quick counter-movement jump and how the participant changes his vertical position. Now to get an understanding between the relationship between position, velocity, and acceleration, we're going to look at how the participant changes his vertical position with respect to the origin at the top of his head, and see how that relates as well to his velocity and acceleration. Now, due to limited resources, I had to assume that the participant was 6 feet tall, or about 72 inches, and I chose the origin to be while standing straight up the top of the participant's head. And in order to get a measurement, I took a screenshot of each second in the video and aligned it with a digital ruler. And assuming that he was 6 feet tall, I chose each inch on the digital ruler to be 0.154 inches and used this to take measurements at each given second in the video. Now, using this ratio, I calculated the position of the origin at each given second in the video and came out to the origin at 0, then dropping down to 19.4 inches, then negative 18.8 inches, to negative 3.81, to 8.5, to negative 14.2, and finally at 6 seconds into the video, ending back at 0 inches. Now, plotting each of these points in Excel with respect to time, I was able to get rough estimation graphs of each one, and I feel that it gives at least a general understanding of how each graph is related to each other. Now, just to look at the position graph, the participant starts at the origin, drops down in the squat in the counter movement jump, and then jumps back up about 8 inches above the origin, drops back down into a squat, and comes back to the origin. This is reflected in the velocity graph from points 1 to 3 seconds, when the squat is at a maximum velocity and then a minimum velocity, goes up in the positive direction for the jump, and comes back down towards 0 when it reaches its apex in the position. Comes back in the negative direction for falling and squatting, and then back up towards 0 for recovery. And finally, for the acceleration graph, it again starts at 0, goes in the negative direction for the squat, back to the positive direction as the participant jumps, reaches 0 at the apex of the velocity, or when the participant is changing position at the fastest rate, and goes generally back in the negative direction as a participant falls and recovers back to 0. I hope that through this explanation and real-world example, I was at least able to give a general understanding of how position, velocity, and acceleration are related to each other, and how you can make a velocity and acceleration graph based off of a position graph.